So, thanks very much to xMatters for inviting me to come here today. The title, my presentation has changed a little since the title was originally written. You can see it's gonna get into some things that are a little technical, a little theoretical, if you will, and I want you to bear with me as I go through this. First slide's a little bit about me. I am an Associate Director of IT Service Management at Vanderbilt University. I have been doing IT Service Management for 12 years. We had a help desk in the change management process when we started the program, but largely as a fully funded program with real full-time staff, it came into being around the time I got involved 12 years ago. Back in 2011, I was asked by a little private Christian university right down the road called Lipscomb University to begin teaching in the College of Computing and Technology part-time. And a couple of years ago, they came to me, they approached me, and they said, "We really like what you're doing, and we'd like for you to pursue a PhD." And so that led to some of the things that I'm doing now. I am doing that. I am pursuing a PhD, working on coursework currently, and hope to be doing a preliminary exam later this year and maybe a dissertation next year. So the reason I mentioned that, and I spent so much time on modeling and simulation, because that has a lot to do with what I'm going to talk about today. Okay, a lot of my presentation is going to be on something known as discrete event modeling and simulation. And the person that introduced me to discrete event modeling was a gentleman you see the picture of, Dr. Larry Dowdy. And I felt very fortunate to have worked under him when I was working on my master's in operating systems performance. Dr. Dowdy is a worldwide expert in the field of operating systems performance and also in discrete event modeling. So he's a great guy. I learned a lot from him. So that gives you a little insight into me. My hero's an engineering professor. That gives you an idea of what this presentation might be like. A little bit more about Vanderbilt. Since we're running behind, I'm going to skip over, very briefly run through these next few slides because they kind of set the stage for what I was going to talk about in discrete event modeling. But basically, Vanderbilt is a large research healthcare organization centered in Nashville, Tennessee. And we truly strive to be the best at everything that we do. This map that you see of Tennessee and the things that are highlighted here are 8 hospital systems that we've formed an alliance with over the past 2 years to form what has become known as the Vanderbilt Health Affiliated Network. So we're in 6 states and 172 counties. The slide says 5 states. Since I created the slide, we've actually formed new alliances. So what this is about is we have experienced explosive growth. We have grown tremendously rapidly over the past few years. What did that mean to us? And what's the context for discrete event modeling here? I'll explain that in a minute. So a little bit about modeling and simulation. This is a DoD definition, and you can see by reading the definition that it's, you can see all kinds of applications for things like military simulations, but you probably don't realize that you use modeling and simulation all the time. Video games are simulations. And the military uses a lot of what we would think of as video games, okay? When you get into Google Maps, and say, what's the quickest way to get to point A or point B? They are doing some modeling the map as a graph and doing a depth first search or a breadth first search to figure out how to get there fastest for you. So these are some of the things that you see as applications of modeling and simulation every day that are hidden behind the scenes. Okay, so how do you do modeling and simulation? Well, first off, you choose a system you want to model, and you model it analytically. Basically, you do the math. You pull some data. You say, how do I think this system is structured? What are the mathematical systems that I could use to model it? And then if that's if you can solve the system analytically, and that's adequate for your needs, that's good enough. And if not, you can do a simulation. And then I'm going to give you an example here in a minute. So on discrete event modeling, what's a discrete event? It's one of those things that occurs at an instance in time. So for the context of what we're talking about today, the context is a call center during 2 use cases. We've got normal operation as well as during a major incident. So the discrete events that might occur during a normal operation or a major incident at a call center would be what? Well, if we're looking specifically at phone calls, someone's going to call on the phone, right? Someone will pick up the phone and dial the help desk or the call center, whatever it is. And the other discrete event that you're modeling is the time that person completes service, right? So what happens, as we all know, if you call and all the operators are busy, you go into a queue. Very simple. Okay, now contrast this with continuous modeling, which is another big form of modeling and simulation. Types of things that you might model there, and I've had to do some projects on things such as this. It's like temperature change as a spacecraft re-enters the Earth's atmosphere. Okay, or the flight pattern of a fighter jet that's trying to intercept a bomber. These are examples of continuous models, okay? But discrete event models are very appropriate for modeling call centers. Okay, so this is a little of the math involved. Please bear with me. Those of you who did not who never took a math class after 8th grade, this is as far as I'm going to go with it. This little relation on top here, which looks like the lowercase p, that's the Greek letter rho, equals lambda, Greek letter lambda, divided by c, mu. Now, I've used these Greek letters because they're in the academic discipline of discrete event modeling. That's what's used to represent these. In all the literature, that's what you see. So rho is server utilization. So modeling a call center, server utilization is what? It's how busy your operators are. Are they on the phone 100% of the time? Are they on the phone 60% of the time? Are they pegged? Are they doing everything? Or are they not too busy? Okay, lambda is the arrival rate of customers. So lambda would be a number such as 10 per minute, 5 per hour. Capacity is the number of servers. In the context of a call center, you're talking about the number of operators you have taking phone calls. And mu is the rate of service provision. In other words, how many calls can an operator handle in a given period of time, whether it's minutes, hours, whatever. And so you want to make sure that rho stays less than 1. So what? Well, if rho gets greater than 1, that means your operators are more than fully utilized, and what happens to your customers? The queue grows to infinity, which is not good. So with a little more complex math, which I'm not going to present today, if you understand the distributions of the service provision and of the arrival rate of customers, you can determine all kinds of things. A theoretical average queue length, a theoretical average wait time, okay? So it's a really powerful modeling technique. And by the way, nothing I'm saying today, there's a fair amount of research out there. There are books that have been written. By the way, Dr. Dowdy wrote a book while I was his student on this very topic, the context being operating systems performance, as I mentioned. But this is all very mature theory. Okay, so customers being queued up there. Move on to the next slide. So back to our explosive growth at Vanderbilt. Back in 2014, we outsourced our help desk. Our help desk had been in place for well over a dozen years, was very mature, and we were trying to demonstrate. We said, okay, we've gone from being a single campus with 4 hospitals and about 100 specialties to becoming a network, a multi-state network. We've experienced this explosive growth. How do we scale effectively if our IT organization scales at the same rate as our other operations? But at the same time, we had to make sure that we didn't let our specialty application support people walk out the door. A lot of those people that were working our help desk at the time had really in-depth knowledge of the patient care applications that we support. And I say we support, we had developed many of these. And even when we purchased off-the-shelf software, we would immediately start to try and figure out how we could do integrations, how we could get data out of them, how we could put data into them. Okay, so we have a very complex network of patient care applications. So we didn't want to let these people from the help desk, all this knowledge, walk out the door, so we created a clinical application support desk for that function. And we had to ask, we didn't know, but those values that I mentioned a few minutes ago, how many staff did we need? How many operators did we need? We didn't have any idea how many calls we were going to get. So this is the initial staffing levels. October 1st of 2014, this data was collected from our automatic call distribution system. And so this shows, you see that little dip at 6 p.m. This starts at midnight and runs to the following midnight. These are 1 hour intervals, the number of staff we had. And you see that little dip at 6 p.m. Actually, when I was looking at the data, that's a fractional dip. So I'm assuming that part of that time anyway, we were having someone dip out for lunch or to take their meal break or something like that. Again, we're looking at the capacity of servers there. Okay, so the arrival rate of customers over that period, this is a month's data from October of 2014. You can see what the call volume looked like. Now, going back, you can see it kind of roughly mirrors what the staffing levels were, but we had times in the morning we had very low utilization, and it kind of peaks up around 10 a.m. and then a dip at lunchtime, and then kind of slowly falls off in the afternoon. Okay, so we've got now from the automatic call distribution system, I've got data where I know how many staff we had answering phone calls, and I know the arrival rate of customers. I also was able to pull how long were the operators spending on the phone. So it's 2.93 minutes per call, or that's 2 minutes 54 seconds. So what could I do? I could model, using the equation that I had earlier, I could model the normal weekday utilization for each hour, okay? And the red line that you see represents utilization of 1, okay? Now, I said a minute ago that we wanted to keep rho below 1 because we wanted to ensure that the queue didn't grow without control, right? You see the numbers at the right there. I noticed that, 35% utilization overall and then 60% utilization during business hours, with a peak of 91% during that 6 p.m. hour where we get down to 1 staff member on average. So what do we think? Is this adequate? We're less than 1. The queue's not going to get out of control. This last month, I pulled the same data again. I looked at everything. I looked at the current staffing levels. You'll see the curve looks fairly similar, okay? But the utilization map looks a little different. And what you'll notice is it's smoothed out a little bit. It doesn't have that big peak out there at 6 p.m. And the peak is still at 91%, but it occurs during the busiest time of the day for the calls. And our average utilization stayed right about the same. The standard deviation stayed about the same, which the standard deviation means that people are getting about the same level of service as they were. Interestingly enough, we've dropped hours. Okay, so we are spending less money on people answering phones over this period than we were a year ago, and yet we've maintained the same staffing levels and the same level of utilization. So now I've proven analytically that we can stay less than 1, okay? Is that adequate? Okay? Are we satisfied with that? Well, I ran a simulation. I thought, let's run a simulation and see what happens. And so the parameters of my simulation, I did 100 runs of 6 hours, 7 a.m. to 1 p.m. And the reason I chose 7 a.m. to 1 p.m. will become evident in a minute. With a 95% confidence interval and using the time variant values of the arrival rate and staffing levels, all the parameters that you've seen a few minutes ago. Okay, and what did I find? Utilization 61%. The range over the 100 runs was 49 to 71%, very close to what I showed analytically. And the wait time that we found from simulation, the range of wait times was 0. In other words, a customer calls and gets right in and talks to an operator, up to 10 minutes, 41 seconds. Okay? Now, is that acceptable? Well, it's not acceptable in our call center. It's not acceptable to me as a customer calling a call center. I don't know about you guys. I'm not going to stay on the phone for 10 hours and 41 minutes waiting for somebody to pick up. Right? One of the things I didn't model in this simulation was balks, which are people that get tired, that they either see the queue length and decide not to wait, or get tired of waiting and hang up. Okay? So, under normal conditions, that's the story. What happens when we have a major incident? And so now this is why I modeled from 6 a.m. to 1 p.m. On October 23rd of 2014, we had a major incident. And this is what our utilization, our analytical utilization looked like. Now you can see the red line down the bottom is still 1, but we are at between 5 and 6 times what we can handle. We went into recovery around 11 o'clock, and you can see the utilization curve start to go down. But still for several hours, we're getting more calls than our operators can handle, right? What is this? I ran the same simulation with the same numbers. And interestingly enough, the average utilization was 100% plus or minus 1.3 times 10 to the minus 14, which with a 95% confidence interval, everyone was on the phone 100% of the time, basically. The range of wait times, again modeled without balks, was 48 minutes to 4 hours and 42 minutes. So what does that mean? What does that mean to us when we're having a major incident in our call center? We expect our call center to manage a major incident, to take all the calls. Now, I thought, okay, so maybe ITIL's got some guidance that'll be helpful in this. And this is pretty much what ITIL says about major incidents. You know, they're saying, okay, the service desk should make sure that all activities recorded users are. In other words, they're saying, don't just answer the phone, but do these extra things, record extra data. We've already established that your help desk staff can't even keep up with the call volume while this is going on, right? So what can we do? Well, the first thing that I'd like to suggest to you is this concept, this metaphor of a major incident jump kit. You have to get your call center used to the idea that we can no longer operate in a normal fashion. Okay? They're trained, you spend a lot of time training them to answer the phone. Well, when you're in a major incident, and a major incident's been declared, and utilization jumps to 5 to 6 times what it normally is, they can't answer the phone. So, I mean, I guess one option is to staff for major incidents, but then your team's going to be utilized about, what, 15, 20% of the time? That's not a good scenario either. You can't afford it. And the other thing, too, is your team will not be sharp when you need them. So, establishing a major incident, you need to figure out when to declare a major incident. That's always been a problem for us, and I still believe that there's more art than science to it. But some guidance on things that you can look at, and your help desk can be very helpful in identifying these things, of course. I think it's this metaphor of the jump kit. You do additional training on doing things different, and one of these things is to quit answering the phone, or at least have a subset of your help desk staff stop answering the phone and do the things that they don't do normally, okay? You need to leverage your mass communications channels. One of the things that we do, we have, as part of our electronic health record, we have an application that's a hub for a lot of other information sources, okay? And it's a web app, so it's very easy for us to go in and put a banner message. Something's gone wrong. It's big. You may not have, this system may not be functioning the way you expect it to. Or this system might work, but you may not be getting data that you need to. So the other thing too is you can use blast messages like xMatters. You can use things like, tools like xMatters and the mass notification functionality of xMatters. And your on-hold messages. If you have an automatic call distribution system that allows it, go in and record an on-call message. This is one of the things that was very difficult for us to get our help desk staff to do. Stop answering the phone and record a message. Now, what are we trying to attack here? Well, we've got, going back to rho equals lambda divided by C mu, we want to bring the utilization down. We're trying to control the rate at which people are calling the help desk, right? These things are all things, if people are calling to tell you about something you already know, or if they're calling to ask when things are going to be available again, that might be something that's of general interest, and you could use mass channels to notify them. Another thing, too, that's come out of the healthcare world that has been very effective for us is to appoint an incident commander. But somebody in IT, a senior leader who understands, who is known and respected throughout the organization, who knows how to translate geek speak into plain English, things that people will understand, who also understands the business and their priorities, okay? And he can maintain communication with the executives. We've already talked, several presentations have already talked about bridge calls, so I won't spend any more time there, okay? But it's important when you have a bridge call is to make sure that you know who is leading the call and you appoint a scribe. The things that are said on those bridge calls, if someone is writing those things down, it can be very important in a debriefing later, all right? And also, too, make sure that whatever bridge calls are there, that you establish what your communication mechanism is going to be before the bridge calls start. All part of your major incident jump kit. And then, of course, maximize the use of automation. All these things that you're doing that are outside your normal incident handling process, to the extent that you can automate them, it makes you more effective during the major incident. So the types of things that you might be able to automate from within your tool, of course, your blast messages, your banner messages, your on-call, even your on-hold message might be, you can automate a piece of it if it's pre-recorded. Okay? So, in conclusion, I'd just like to thank you all for listening to me today, and thank xMatters for inviting me here, being so gracious. I'd be happy to talk with any of you if you have any questions.